Hi, and welcome back to Andreas Garden. I was asked to do a video clip of the airlift system, which is running the DWC. So I'll go quickly through it and give you a quick breakdown of how I did it. These are the pair of airlifts. Okay, these are just straight 3/4. I put 45 elbows on the end, and that gives me a nice circular flow pattern within the tank. Two, again, to keep the water moving more evenly than as opposed to one airlift. The two 3/4 give me a decent lift. As you can see inside the collector, the water is roughly 100 mil, maybe a little bit more down inside the tube. Again, these two 3/4 handle that easily. They're set at the moment at 1300 litres per hour. I can turn it up, I can get them running at roughly 1700. The airlift is fed directly from the bottom of the DWCs. And the water, as you can see, drops down into the 2-inch, comes through here. There's another drop down there from this DWC, running through here and then dropping down into the sump. The air comes from the common manifold through 6mm irrigation pipe. There's just a pair of aquarium adjusters there, and that enables me to get them flowing as I want. I can have one stronger than the other, or both at the same rate, and then I time them in on a 4-litre bucket, accurate enough for what I want. The pair set up like that with the 45 elbows on, as I said, give a nice rotational flow, and you can see how much water is moving and going down through. There's the standpipe for the bottom drain. The bottom drain is slotted at the bottom, takes about 30% of the flow. The rest goes down through the standpipe at the top. And you can see that lovely teacup effect on the top. So it skims the top of the surface. Any food left over, floating poo, goes down and ends up in the RFF. It's difficult to see through the reflection, but I'm very pleased with that. Here's the power supply for the airlifts and the rest of the system. The far one, this one here is 60 litres a minute. This one here is 40 litres a minute. Both of them at 37 watts. The airlifts, I think I could get those down. I could run an air pump of maybe 10 watts and it would still give me what I want. I've done it this way because I need to feed the two DWCs, pump air into those, plus the MT, plus I got a little bit spare at the 100 litres a minute. I've got another one here. That thing there is 7 watts. Now it's 7 watts. There isn't really enough poke in that to run those two airlifts. I have tried, and I can't get a flow. Maybe it's not far away, but at least doing it this way, I've got the extra capacity and I can adjust the flow to what I want. Okay, airlift design. The two 3/4 over there in the for the DWC are about as simple and as basic as you can get. I did try several designs, and believe it or not, this simple little airlift here does work the best. It's basically a 3/4 T. This is a prototype I was playing around with, so it's got a hole in the end cap which isn't there on the other two. In the top there is a irrigation fitting. Whoops, I just dropped that on the floor. As you can see, it's just open all the way up through. There's no restriction. In practice, I pump the air in through there, it bubbles up through the tube, and it works very, very efficiently. Those two over there are just about the depth of the tank. So I think the tank's about 600 mil deep. So it's 600 mil. I think the airlifts are a little bit more than that. I think they're about 700 mil because of the way the elbows fit into the top. It'll still pump up to 1700 litres an hour. Efficiency, I think it's around about a 1300, and then I've still got a lot of air spare for all the rest of the system. And here's another version of the 3/4. This one, I made a small compression chamber at the bottom. Again, it means that the airlift is restriction free. This is just made up of various types of pipe, size of pipe that slot over each other, just held together with glue. The actual riser itself has lots and lots of little holes. The actual one inside of this, the holes are smaller, and there's another 2 rows. After experimentation, I found that worked the best. This one worked very, very well in the MT. It was pumping a lot of water and moving a lot of solids, and in fact I'm going to go back to that. At the moment I'm using 2-inch, and I think these 3/4 are better. Right, here is the 2-inch compression chamber. This is manufactured with these 2 to 3-inch reducers, with the internal section there just fractionally longer. So when you press it together and glue it up, it becomes airtight. You can't see it now very well because it's been in use and it's dirty, but inside there is a series of very small holes running from the top right down to the bottom. They're about 3/4 of a mil. That was about the smallest drill I could find, actually. And this gives a very fine curtain of bubbles up through the riser. 2-inch pipe on this works well, but at the depths I've been trying it, it has practically no lift. So that's why we went over for 3/4. What I have been trying is, I'll stand up so we get a better shot, is this riser, which is manufactured from 3 pieces of 3/4 pipe, and it basically just siliconed into a piece of 2-inch, one at the bottom, one at the top. The hope with this was it was going to give me lift. It's been cut off now because it didn't really work. I think the air injection method wasn't very good, but this one's been running in the MT tank. It just gets placed in there like that, an elbow on the top, and that is used to agitate and aerate the MT tank. But I have tried various other designs of airlift, flares at the top, flares at the bottom, but at the moment for me nothing works much better than these 2 little 3/4 airlifts here I'm using at the moment. Well, I hope this has been useful. Any other help, please just comment and I'll see what I can do. Okay, thank you very much. Bye bye.